So implication, it takes two statements and outputs a single statement. And I'll give you an example. So the dog X is an animal under implication. We construct if X is a dog, then X is an animal. Okay, so it's like an if-then statement. This is the basis of a lot of the things we do in logic. I mean, in math, the formulations of the statements that you end up studying and proving are, if assumptions, then conclusion. So let's talk about the truth values of this operation. So can you see how? So in this particular example, when X is a dog, okay, then it actually is an animal. So we can agree that the right hand side is just a true statement, and it's a true statement for every X. It doesn't matter whether, so if X is a dog, then it's certainly an animal, and if X is not a dog, well, the statement doesn't have any pressure to be true or to give you any conclusion at all. So if it is a dog, then the first statement is true, okay, and then it's also an animal, so the second statement is true, and then we just said that the whole statement is true, okay. And then we also said basically whenever X is not a dog, and when X is not a dog, it could be, say, like a cat, or maybe it could possibly be not a non-animal, so it could be maybe like a plane, okay. And these things, well, we just said that the statement has no responsibility to do anything in this case, so it still remains true, If X is a dog, then it's an animal. So, but since X is not a dog, it doesn't have to be an animal or anything. So whenever it's false, the implication is still true, okay? So I'm saying the implication is true, not necessarily just the conclusion, okay? Because if you take a plane, then it's not an animal. So it's the then is not satisfied, but we don't really care about that because we care about the whole if then. So if the if is not satisfied, we don't even look at the statement anymore. So whenever it's false, so whenever X is not a dog, and then it doesn't matter whether X is an animal or not. We don't even care whether it is or it's not. The statement will always be true. Okay. And so there's only actually one way that a statement like this could be false. If you could have something that was a dog, but it wasn't an animal. Okay, so it doesn't exist in this particular case. But like if the conclusion wasn't that it was an animal, maybe the conclusion was that it was, if X is a dog, then X is a horse. Then you just pick any dog. That dog happens to not be a horse. So it's a dog means the first statement's true. It's not a horse means the second statement's false. And this is explicitly showing that the output statement is false, because you basically gave an example that illustrates something that satisfied the if but not the then. So the only way for it to be false is if you have the if is true and the then is false.